I think most people expect a material like concrete or steel to be inherently safer than wood because they have some sort of perception of wood being flammable or combustible. From my perspective as a structural engineer who specializes in mass timber, there are so many misconceptions about the way mass timber performs in a fire. But here we'll talk about fire safety, including addressing common concerns. Now, when I first started working in this industry, I had the same questions everyone else had. Like, why would anyone consider building with wood when we have materials like concrete and steel that are clearly non-flammable? Well, after a lot of research, I discovered that the answer isn't straightforward, but it's incredibly interesting. People imagine these large timber trusses or whole timber buildings going up like a tinderbox, which they would if they were single pieces of wood. There is some truth to this because we are all that familiar with firefighting techniques for large-scale timber structures. But I think this issue can be resolved by providing resources to first responders to train them on how to fight fires in these buildings. These coatings are typically applied as a liquid and they expand when exposed to heat, which helps to insulate the wood and prevent it from igniting. We can also use sprinkler systems to help protect timber buildings in the event of a fire. I was really excited to learn about this topic because, like I said, I started my career assuming that mass timber wasn't safe to use in large-scale buildings. But the reality is it actually performs really well in a fire. So that brings us to the end of another episode. Thank you for tuning in. You liked what you saw? Hit subscribe and check out the rest of the series. We hope to see you in the next episode of Green Build Insights, where we discuss modular mass timber and why off-site wood assembly could revolutionize how cities grow. I'm the host. Until next time, where sustainability meets engineering. Mass timber has been tested extensively to determine its fire resistance, and the results are impressive. For example, cross-laminated timber, or CLT, is a relatively new material, and it has been around long enough to have tested in an actual fire. However, it has been tested in laboratory settings. In a recent study conducted by the University of British Columbia, a full-scale CLT wall was exposed to a 2-hour fire and it didn't fail. It continued to maintain its structural integrity even after prolonged exposure to high temperatures. This is a significant achievement, and it demonstrates that CLT is a promising material for use in high-rise buildings. Sprinklers are effective at cooling the timber and preventing it from reaching a critical temperature, and they can also help to suppress flames and reduce the amount of smoke. But because mass timber is an engineered product, it's built in a way that compartmentalizes the fuel source. Well, that depends on a number of factors, including the thickness of the component, the type of wood that's used, and the intensity of the fire itself. In general, however, mass timber components are thicker than traditional lumber, which means they take longer to burn. As I mentioned earlier, they also have char layers that form on the outside, which further slows down the burning process. The first thing that happens is called charring, which is a process where the outer layer of the timber heats up and carbonizes. This layer acts as a protective barrier for the rest of the material and helps to insulate the building as structural components. In addition to these studies, mass timber has also been tested in real-life scenarios such as the 2017 Thomas Fire in London. The fire caused extensive damage to the Grenfell Tower, which was clad in flammable materials. However, the neighboring timber buildings were able to withstand the fire and protect their occupants. This is a testament to the fire resistance of timber and its ability to perform well in high-rise buildings. Now, it's important to note that charring doesn't mean the wood is burnt up. Instead, the charred material is still structurally sound and can provide additional strength to the timber member. So instead of trying to prevent charring, we can actually use it to our advantage. For example, we can control how thick the charred surface is by varying the thickness of the timber component. By controlling this charred depth, we can increase the amount of time it takes for the underlying material to reach a critical temperature. One great example of this is cross-laminated timber, or CLT. With this specific product, the individual pieces of lumber are oriented at different angles, which prevents the fire from traveling from one face to the next. Another common concern is that mass timber unachieve the level of fire resistance required for a building to pass code. But again, this is incorrect. Like I mentioned earlier, mass timber is an engineered product, which means we can control the fuel source. We can also increase the level of fire resistance by adjusting the thickness of the individual component. And I want to address some of those today. I'm Erin Walker, a structural engineer specializing in mass timber construction. A typical combustion reaction requires 3 basic ingredients: fuel, oxygen, and an ignition source. Of those 3 elements, the only one that we really have any control over as structural engineers or architects is the fuel. And what we find interesting about mass timber is that it's an engineered product. It has a certain amount of fuel in it, and it's predictable. It's unlike a piece of furniture that you can't predict how long it will burn when you're using a solid timber product. You can determine how much wood is in there and therefore how long it will burn. So if you've been following along with the series, you've probably already learned that mass timber buildings are healthy, sustainable, and strong. First, let's talk about the physics of fire itself. What actually causes something to ignite and burn? Now, before we get into how mass timber reacts to fire specifically, let's look at some of the biggest concerns surrounding it. First, toxicity is a huge concern whenever we're talking about a fire. People assume that wood is going to release these dangerous toxins into the air and cause cancer. But this is untrue of modern mass timber products, because they remade with low-emission formaldehyde and urea formaldehyde binders. And also, they don't contain added chemicals that make them more combustible. Instead, the natural oils within the wood itself act as the primary fuel source. This is a huge misconception, and it's an important thing to point out, because the reality is mass timber produces a tremendous amount less smoke and toxic gases than many other building products. For example, paints and varnishes release volatile organic compounds at a rate that's 100 times higher than wood. The second concern is the potential for rapid fire spread throughout a building. And finally, the last concern is the lack of familiarity for first responders. So what actually happens when mass timber is exposed to a fire? In addition to designing for charring, we can also use intumescent coatings to help protect the timber in case of a fire. You might be wondering how long it takes for timber to burn. Now, let's talk about the actual fire performance of mass timber. Another study conducted by the Building Research Establishment in the UK showed that a CLT panel withstood a fire at 1,000 degrees Celsius for over an hour. To sum everything up, mass timber is considered fire-safe when it passes full-scale fire testing, when it complies with updated international building codes, and when it features a well-integrated fire system design.